Susie,
Rob,
in the very first episode of the Fossil Files, we talked about plesiosaurs, and you mentioned who was it who put their head on the wrong end?
I think it was Cope, wasn't it?
Cope. So Cope, at the
Famous
very
American fossil hunter,
famous
Cope.
American fossil hunter, put the plesiosaur head on the wrong end, and starting off a long tradition of fails in paleontology. So we're going to be covering a couple in the next couple of episodes, um, in a nice way, of the more recent fails or misunderstandings from the world of paleontology, starting with some bees. So, Susie, have you made any mistakes in your professional career? This is probably the wrong question to ask at this stage.
Absolutely never.
Never, never.
Never.
Same. So that's the end of
Yeah,
that.
well,
So,
there we
no,
go.
no.
Well,
I certainly have. I'm sure I have. I'm not sure about the scale of what counts as a mistake or a fail or a problem, but there were just a couple of more interesting, amusing ones that I want to talk about. They're also, we've selected a couple of examples because they give us an opportunity to talk about paleontology, how it's done, and some of the bigger issues surrounding it. So I have one that I want to talk to you about, first of all, that actually come from 2023. So Susie, I mean, we talked about before, but because you're in the world of the Mesozoic and the dinosaurs, you don't spend a lot of time thinking about what goes on hundreds of millions before that. But I mean, you're at least aware of the Ediacaran period, right?
I am. It's actually one of my favorite geologic periods. I think if I had to pick one, I think it would
Oh
be one
yeah.
of my favorites. Yeah.
So
Yeah.
why is
I
it your
imagine it,
favorite?
well, I just imagine it being a very calm place to be. So you
Yeah.
think, like not no predation, just
Hmm.
a load of kind of, soft body things drifting about. I imagine, but if you need to meditate, I think imagining that you're a sessile organism, a
Yeah.
sessile Ediacaran attached to the bottom of the Ediacaran Ocean might be
Yeah.
a real kind of calming thing
No
to think
brain,
about.
just sat there.
Yeah.
Yeah.
Yeah. Just filter feeding, doing your thing,
Yeah.
swaying in currents.
Yeah.
Very relaxing, wouldn't it?
So to give people some context, we're talking about the episodes immediately preceding the Cambrian. So with the Cambrian, we talked about a few weeks ago, where it's the explosion of animal diversity. We see a lot of life suddenly arriving on the scene. It's a mad case of evolutionary dynamics. But immediately before that, we have this much more cryptic and slightly bizarre world where we have sort of tantalizing impressions of fossils without any skeletons, although it depends on what you call the things in Namibia. But anyway, let's say that they're soft-bodied for now. And they are living in this very flat microbial world. Um, Not a lot there's some debate about whether they are or are not animals, and some debate about whether they are or are not living in the sea, but we'll come back to that later on.
Can I ask a quick
So
question here?
go for it.
Just for clarity's sake. Now, when I was an undergraduate, which was a long time ago, Rob, I
You have to
remember,
whisper that just in case.
just in case anybody hears how long ago it
Yeah,
was,
yeah.
that at the time the Ediacarans were thought to be single-celled organisms. Now we're that's like well gone, right? They're
Hmm.
now,
Hmm.
oh, there was a bit of debate that they were like these giant single cells, but now we're very happy that they're multicellular. Why do we think that they are animals?
Right. That's tricky because I could spend a long time talking about it.
Can you give us like
Um,
the really short version?
well, what you should do
Just you
is
could say no if you want.
pay your £9,000 tuition fee to come and join the University of Manchester, and I'll give you a series of lectures on it. How about that? No, well, first of all, just to give some, what we've got these flat microbial mats, just for the, I know you know this, but this is for the purpose of everyone else. And then we've got these in compressions. They look a bit like pillows. They've kind of got these hints of what look like symmetry. Do they have a front end or a back end? You don't really know. They look, a lot of them are just blobs. They have fronds. Some of them they look like leaves, but animally. So why are they not single-celled organisms? We kind of the structure is a bit more complex than that. But why are they animals? Well, that depends on which one you're talking about. They don't really seem to move a lot. One of them seems to move around, which indicates that it might be an animal. That's Kimberella. It does actually seem to have traces of it moving, and moving about like that would make it an animal. Some of them more recently have been found to have what look like muscles. And if you've got muscles, then you are an animal. But also, it's hard to try and get the short answer is it's difficult. You have to use a lot of complicated methods and techniques to try and get into this. You might use some geochemistry. You might look at their arrangement in space. You might look at their size, their taphonomy. It's hard, but there's a lot of work going on at Oxford, Cambridge, and other places where they've been slowly building this picture over a long time that they represent what are likely to be earlier animals. that hasn't given you a direct answer, but there are lots of indirect lines of evidence that might help you build up the idea that they are kind of animals. And one that we're going to talk about is Dickinsonia. No giggling, please. Dickinsonia is the name of the fossil. It is Susie's rolling her eyes. It is a one of these classic Ediacaran ones. It's like a little pillow with the left-hand side and the right-hand side, and it sort of might be moving about, eating a bit of the mat, then drifting off, but not moving about like walking, but just like picking up, drafting, and then plocking down again. So that's all the fascinating stuff that goes on in the Ediacaran. That's the current state of affairs when this paper comes in. I'm talking too long about the Ediacaran. I must move on. So a paper came out in 2021 by Greg Retalak. Now, Greg Retalak is already coming with a bit of a controversy behind him here. He's already somewhat of a maverick. So he is an Australian paleontologist living in the US. He is at odds with a lot of the Ediacaran people because he says that they are terrestrial and they are lichens. Everyone else says that they are, well, lichens or fungi type things. He's an expert in fossil soils, and he says that he looks at these things and they're living on land. Almost everyone else disagrees and says, what are you talking about? These are clearly marine. Get in the bin.
I've got to
And
say, right? I mean,
yeah,
I know these rocks are old, like they are,
yeah, yeah,
a billion years old,
yeah.
or thereabouts.
Hmm.
You can still tell the difference between marine and terrestrial rocks.
Yes,
Like,
yes, you can. Yeah,
you
yeah.
can.
So
Yeah.
I think we'll say he's a bit autapomorphic, shall we? To refer back to our previous episode. He's at
Okay.
odds with a lot of the people. I mean, Shu Hai Zhao has written a fairly clear takedown of this, saying, look, there's ripple marks, right? There's shale. It being the ones in Australia being red, that's not good enough to say that it's terrestrial, right? There's lots of ways that a rock might become red. Anyway, I don't want to go into the arcane conversations about fun a bit. But that's the context important for this paper. The paper that came out in 2021, Gondwana research, Dickinsonia discovered in India and the late Ediacaran biogeography. I'm probably saying Ediacaran wrong because Ediacaran, I don't know. We'll get corrected on
They
this.
don't mind. You know what? They
They don't
didn't even
mind.
have brains. They don't mind how you pronounce their time period.
Okay. So this is by Greg Retalak and some collaborators in India, Ranjit Kanjar and others. They so this is quite a big deal, this paper when it came out. So it's in Gondwana research because this is important because this might help us to do some biostratigraphy and also it'd help us with the time frame. So they've got this Dickinsonia. They report this picture of this thing. It looks a bit like Dickinsonia, I guess. We've got these pictures of it uploaded in the picture. Now, the interesting, quirky thing about this is that it comes from this really interesting place in India that I'd not heard of before, called. Let me refer to my notes. I'd written it all down,
It's
and
the
now I
Upper
can't find them.
Vinhayan.
Oh, you know. That's the name of the group of the rocks. So
That's the
they've
group.
got
No,
this
that's the name of the
massive.
group of rocks.
Yeah. So we've got the Vindayan supergroup, but actually the specific locality is in
Ah,
the Bimketa
Bimbek, Bimbek. Ah,
Bimteka rock shelters. Now, what's interesting about these is that they are it's a UNESCO World Heritage Site already because it's the site of the earliest human occupation in India. So these fascinating caves with the cave art from maybe 100,000 years ago
wow.
of people getting attacked by bison, dancing. It's a really interesting, fascinating place. It's right in the middle of India near Bhopal, site of some unpleasantness in the 80s, but we're not going to go on about that, I guess. So it's a UNESCO World Heritage Site, which also has implications about being able to get access to it, go there and just collect fossils and do things. It's highly protected because of this massively important cave art right in front of it. So these guys reported when you look up at the ceiling of this cave, they found this range of Dickinsonia. They did some
Well, they found
photogrammetry.
one, right? They found one. Did they find more than
No,
one?
no, they found about three collected on top of each
Oh,
other, and they said it looked a bit waxy with maybe some soot on top of it. Oh, the other thing that makes this a bit difficult is that the Vindayan supergroup, this massive block of Indian rocks, it's the age estimations from isotopes range from 500 million years to 1,500 million years. So we've got a massive error bar on this. And what that they say, we found Dickinsonia, therefore we can constrain it because we've got a very constrained idea about what that is because Dickinsonia only is around 500 million years old. So that's great. So that it also implies some interesting things about biogeography. Okay, nice story. And obviously they interpret it as being terrestrial because that's Greg Retalak, that's what he likes to do.
it's
Then
massive, fat, thick sandstone that the
Mm.
cave is in.
Yeah, yeah, yeah,
Solid terrestrial rock. Okay, carry on.
yeah,
Carry on.
yeah.
Yeah.
So that was the context. But then in 2023, this achieved a bit of interest because two papers came out very close to each other. Let me find them.
Good. Yes.
Dickinsonia, reported by Retilac, is not a fossil, instead an impression of a extant fallen beehive by S.K. Pandey and colleagues of India, published in the Journal of Geological Society of India. And then the one that I'm going to be focusing more on because they put puns in it. Stinging news. Dickinsonia discovered in the Upper Vindhyan of India, not worth the buzz,
Oh,
by Joseph Miat
amazing
and
title.
colleagues, Manjot Pandit and Samuel Quaffer and Anaya Singha, published in 2023 in Gondwana Research. They got two puns into the title
May
of
I
this thing.
compliment Joseph Miat? You're a genius.
Right? So both of these guys, the SK Pandy one's quite interesting because they went to they tried to get access to this but couldn't because it's UNESCO World Heritage Site and it was the pandemic. So this is like, you're sympathetic, right? They said they had to quote consistent persuasion was the quote they've used in the paper they finally got in there. I don't know what went on behind the scenes, but that kind of tells the whole story. So eventually they got there and then they looked up and were like, oh, good God. They found they found beehives everywhere. These massive beehives. So this a giant bee. So this isn't like some nice like tiny little quaint. Oh, let me make you a little bit of honey. These are enormous beehives that I think would just scare the bejesus out of me if I was to walk past them. The other team also went and visited. They made two observations. One, there are giant beehives everywhere. And two, the fossils were not located on the bedding plane. They were some of them. These fossils were on the fractures. So this waxy substance was on the fractures of them. Number two, they were degrading and flaking away in the wind. So they've gone back to the exact fossils, and they're lopped off. Now again, when I first read that, I laughed to myself because I was like, oh, well, obviously that. But then actually, then I thought about it. A lot of these Ediacaran fossils are actually getting lost to time. Some of the ones in Newfoundland, they're in the coastal tidal zone on this.
Mm.
They are going to get destroyed and washed away eventually. Although more damning, there's honey and pollen all up in it. And so, and finally, the one that they reported on actually has honeycomb structures within it.
Yeah.
So, ouch. Now, there's not much more to say about that because that kind of is like that. This what's quite fun about this is it isn't some like massive magical technique. It's more like actually we went there and had a look and went, yeah, there's loads of bees. What are your first thoughts?
I mean, I'm just absolutely gobsmacked that the original authors didn't notice the the bees. I mean, in this paper, the one with the puns that you sent me, their
Yeah,
first figure. Oh, well, no, it's their second figure.
yeah,
They show a bunch of these beehives that are sort of
yeah,
dangling off
yeah,
exactly in the kind of, as you say, these overhangs, these fracture
yeah.
surfaces.
Hmm.
And this is really important, right? Because the way that Ediacaran fossils are preserved is that they are, we have bedding planes, we have layers within the rock, which would have represented momentarily a surface that would have been the land surface or
Hmm.
the
Hmm.
bottom of the sea surface, unless you're Greg Retilac.
Hmm.
So the bottom of the sea at any one time, the seabed. And so these animals are lying on the seabed. And then, so you don't see fossils like between the beds because the beds tend to be deposited probably in
Hmm.
a single event, a storm.
Hmm.
Storm deposits a load of sediment, and then
Hmm.
there's a new seafloor. And so you only, very often you have these sorts of fossils concentrated on the bedding planes. And so you're not going to see them on a fracture surface. They just, and especially lying flat on a fracture surface, it would suggest that the fossil was sticking up kind of
Hmm.
through the bedding, wouldn't
Hmm.
it?
Hmm.
It's very unusual. It, I am gobsmacked that I mean, even an undergraduate geologist would surely notice the problems, that those sorts of problems, that these aren't bedding planes, they're fracture
Hmm.
surfaces. And then on the fracture surfaces, you've got these massive oval bee-like structures, which also produce a waxy material, which they
Hmm.
noted the fossil was preserved in.
Yeah. So I
Just
agree with a lot of
spectacular.
that. So just a bit of context on that, because probably should have entered that in the context at the beginning. I guess I did touch on it. A lot of these Ediacaran things are very flat, two-dimensional bedding plane surfaces with the fossil sort of in situ embedded where they would have lived and died in life, right? So they're very flat. So the bedding plane thing is very, very important. And then, as the microbes build up, then you got new layers. It's all why am I doing it with the hands? It's against there's an audio. I've still not learned that miming is not the way to get across in an audio situation. You've got a flat layer, but the bedding plane of it is very, very important. Now, in their defense, um, it's a UNESCO World Heritage Site, so getting on a ladder and going and having a look and chipping bits off and doing more of it was obviously going to be difficult, right? This is above a cave of like really massively important archaeological context. Second of all, and this is in defense of the original authors, I think I could see myself doing something a bit like this because of pareidolia, or the word I can't ever pronounce. Pareidolia, which is your inherent pattern searching and finding ability. Humans are really, really primed for this. We are awful at it. When you can compare, I mean, I say humans generally as if we are different, but to other animals, but we are pattern hunting people.
It's why
We
people see Jesus's face on slices of toast and stuff, isn't it?
Yeah, exactly. It's why we see patterns everywhere. If I look up at the clouds now, I'll see some smiley faces. Now, those are all like arcane, harmless examples that we all laugh about. If I cup open a pepper, I'll see a face looking at me like, "Arr," or I'm walking past some street architecture and I'll see a face. We look
Yeah,
for
but
faces,
Rob,
we look for
Rob,
patterns.
Rob,
Yeah, yes,
Rob,
yes, 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 yes.
when was the last time you then sat down and published a paper in the international peer-reviewed literature on one of these smiley faces that you've seen in a pepper? I mean, come on, just some basic sort of, I don't know, scrutiny.
Yes, yes. However, I think you're right. I was, however, going to go say that if you're a paleontologist, right? Especially, I mean, the example is my PhD, right? When I was doing my PhD, I basically lived, breathed, and ate these fossils. That was it. I would close my eyes at night and I'd see like osteostracan head shields everywhere. I'd see their shapes. And one time my mum sent me a plate from, had like an abstract pattern on it. And I immediately thought, oh, how did she get that? She's got Gemoitius all over it. And I was like, no, of course no, she didn't buy this plate because she thought it had Gemoitius fossils on it. It was just my brain was completely primed for it.
Did
That's
you write a paper on it though? Did you write a paper on it?
You're not going to let that go, are you? The point is, I think you shouldn't let it go. But the point is, I guess when you're so deeply, deeply, heavily involved in it, maybe you're looking for the pattern. And if someone gives you a phone call and says, "Hey, I've got this cave in India," and it's in these sorts of rocks that might be of this age, and if you look at the pictures of it, it's not a million miles away, right? I mean,
Do you think, I've got a question for you, Rob. Do you
yes,
think
yes.
that Greg Retalak ever actually went to look at this thing? Do you think the Indian co-authors were there, took a photo? Are the Indian co-authors geologists? Are they paleontologists? Did they just take a photo, send it to him, and say, "I think I've got a thing," and he went, "Oh my God, you've got a thing," and then they wrote a paper on
Um,
it?
well, that I think it would be more understandable if that was the case, but I don't think it is the case. I think it was in the author contributions, they are listed as having equal. Um, Let me go back to the author
Yeah,
contributions.
but the author contributions are always made up, Rob,
Yeah.
aren't they?
This is to declare that we, Greg Retalak, Sharad Master, and Ranjit Kandar, and Merajuddin Khan, all equally shared equally in the fieldwork and the study.
Oh, okay.
So
So they
they
all
said
did the
it
field work together.
very explicitly in the author contributions that they all went there and did it together.
So they didn't, he has really no excuse for the fact that he
Yes,
didn't notice
yes.
the enormous giant bees.
Other than if it's in a, oh, I see what you mean. Well, I'm thinking that it's a UNESCO World Heritage Site and it's difficult to get access to. That might give you some
Well,
distance,
you might
but
not. I mean, they've got a good photo in the paper, right? It
yeah,
was a high enough resolution photo that the authors of the punny paper were
yeah,
able to zoom in and identify honeycomb structures.
yes,
So they must have got, some decent photographs. They were able to take some
yes.
decent photographs.
Well,
They
the
were
other
able to get that
team,
close.
the second Indian team that went, the SK Pandey,
Yeah.
they were able to take some specimens for Raman spectroscopy. They were able to get up
Oh,
there and flick some off and find out. Do you know what they found out it was made of? Take a guess.
sandstone and wax.
Wax.
Honeycomb? It was wax.
It
Okay.
was wax. It was beeswax. Yeah. So they,
Bees-
when they submitted it to some Raman spectroscopy, they were able to demonstrate quite specifically that it had hexanodoecoic acid or whatever it was.
Do you know what
It
they should
was
have done here? They should have
yeah,
used my favorite geological technique, geological and
yeah,
paleontological technique. Do you know what it is, Rob?
taste.
Yeah,
Were you going to lick it?
absolutely. They
Yeah,
should have just licked it because then they would have been like, "Oh,
yeah.
sweet, it's honey."
You can't go around licking UNESCO World Heritage Sites. That's
Can you
not
imagine the
allowed.
paperwork?
Yeah.
Sampling
In
technique. Well, I'm
in
only
the
going to be licking
pandemic
it.
time too, you'd have had to have taken your mask off to do it. What do you do? I won't be going around licking my fossils in the Ediacaran to find out if they are or not there. Okay, but I think the point I'm trying to say is if you've got a search image, you are very much going to find it. If you look at Dickinsonia over and over again, you'll find Dickinsonia. Now, that leaves a question open whether or not Dickinsonia has enough characteristics in it to make it, a unique, interesting taxon, which is kind of weird because there's loads of them and they're really nicely preserved. But it's hard when you're dealing with things that are on the border of being a fossil, not a fossil. They're preserved, a lot of them as impressions. Yeah. I
Now,
also just I don't want to be mean about it. That's all. That's the other thing.
well, that's very kind of you. I have a question. Did we only get did we ever hear back from the first team about this? Was there any? I mean,
Yes,
there was a bit of
they've
media
taken it on
about
the
this,
chin.
wasn't there?
Yeah,
Have they? Have they?
they've taken it on the
Yeah.
chin and just gone, yeah, that was a mistake. Yeah, whoops. Which is to their credit. That's to their credit.
Whoops.
I think, well, I mean, or maybe it's just the scale of the problem is too hard to deny. I mean, the Mietz team were quite kind in the end because they said, well, we can't definitively prove that they are not to this, but we can say that we have all these beehives, we've got this honeycomb, we've got this ramen,
The weight of evidence.
well, on the balance of evidence, we might say that they are not, in fact, Dickinsonian. But I thought it was a really interesting cautionary tale about pareidolia. And I was going to pivot this to use an example of a different mad case of pareidolia that I haven't sent you in advance. I'm going to
Oh,
send you it now, though.
okay. It hasn't got any shocking photos in, has it, again?
No, 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 no,
Just like to
not
be
this
prepared.
time.
Oh, oh, ooh.
Okay, so I have just sent Susie a link to another paper called Dinosaur Eggs with Fossilized Embryos on the Moon. Now, that is a hell of a title. That is
I,
a hell of a title,
I'm,
right?
I, I don't know where to start. Oh my God. The New
Susie has been
York
rendered
Science
speechless. For the
Journal.
first time ever, Susie is speechless.
Wow.
So, this paper was published in 2023 in, I'm going to say a journal. I'm not going to
It's
say a
the
journal.
New York Science Journal. It's not one I've ever heard of before,
Let's
I'll
be
be
clear.
honest.
It's a shady predatory journal, right?
Oh, okay.
So, Harry Mohan Saxena and Yagmohan Saxena, brothers, presumably, I don't know.
Maybe.
Um, they published this paper. They like to look at images of things on the moon. Now, I didn't realize this, but NASA have uploaded, really fine detailed scans of the entire moon. You can just scroll around looking at the entire thing.
Oh, I wonder if it's all been taken down now.
Oh God, yeah,
How
that's
sad.
possible given the new political climate.
Yes.
But let me bring up this paper. Where's it gone? I've lost it.
It's in the link. You just sent it to me.
So yeah, sorry, this is chaotic. So in this paper, they have highlighted some images from areas of the moon that they think have the morphology of a sauropod dinosaur embryo. What are your thoughts?
I mean, I am genuinely speechless. It is that I have to say, figure one is
Yeah.
is one of the funniest things I have ever seen in a published scientific paper.
So
It's
describe to
like,
us figure one. What are we looking at?
well, there's no scale bar, so it's difficult to know whether I'm looking at like the whole moon or just. I'm assuming it's a very high resolution zoom in.
Yeah.
And what it is, it's kind of got a blue knobbly background, and then there's a yellow circle. Um, and inside the yellow circle is a blue knobbly thing, which you know, what are they called? Sea monkeys, like you used to grow in a tank when you were little.
Mm,
These like
mm,
they're little.
mm,
What are they? They're little tiny. I don't know. They're little tiny arthropods or something,
mm,
and they look a little bit like little tiny prawns. So it
yeah.
looks a bit like that, and it's really funny because it's got a number of legs, and then it's got like a round face with two eyes,
Yeah. Yeah.
and a sort of some sort of mouth apparatus thing. It's hilarious. What I tell
Th-
you, what it doesn't look like in any way is a dinosaur embryo. Doesn't look anything like any sort of dinosaur embryo that has ever been seen.
Okay. So I feel really bad giggling about this, but these guys have been doing this for a while. They've been looking at these images of the moon, putting them through filters, and looking for images, and then describing what they found.
Right, have you
Uh,
seen the second reference? Have you seen the title of the second reference in this paper? It's by the same
burial,
authors.
burial, burial pits with animal and alien skull-like structures present on the south pole of the moon suggest that humans and or aliens might have existed on the moon for some time. in the same journal. It may not surprise you, no. So this is
No.
this is brilliant stuff. Now, when this paper came out, Jordan Bestwick first was the one that posted it and brought it to my attention. I had to do a sort of spit double take. I kind of got a little bit obsessed with this when I had about 16,000 things to be doing, marking, grant reviewing, writing. I went on a bit of a deep dive into these guys because I was also thinking about this pareidolia thing. And it's because this little sauropod embryo has his eyes. And as you already noticed, I noticed that it doesn't have a scale bar. So I took a deep dive. I went onto the coordinates that they shared, went to the NASA. I had to go and find the NASA documents with the maps, go and find it. And then
Now,
I
hang on a
tried to
sec, hang on a
make,
sec. Leaders, listeners, I would just like to say at this point that Rob is one of the busiest people that you will have ever met. He teaches a very large number of students. He has a number of PhD students. He has a series of
yeah, yeah,
responsibilities on
yeah,
various
yeah,
professional
yes, yes,
associations,
yes,
which,
yes.
and he's not always the best at replying to emails. And now
No,
we know
no.
why.
Because I went in to find these maps and download the images to try and figure out how big this thing is. And image number one, this sauropod embryo. Do you want to know how big it is?
How big is it?
It's 10 kilometers wide. It's 10, it's 10 this baby dinosaur on the moon is 10 kilometers. So, oh God.
Oh dear.
I think we may poke a few holes in this hypothesis.
Oh my gosh.
Now, so let's take a step back then and stop being mean because I'm being mean now. Pareidolia is a very real problem that we have to think about as fossil paleontologists. Like when you're looking at your ankylosaur histology, how do you know it's an ankylosaur? When you're looking at your
It was an
it
ankylosaur, though, wasn't it, Rob? It was an
was
ankylosaur.
an ankylosaur. And when you're looking at your 10-kilometer wide embryo,
Baby
you need
dinosaur.
to be careful. Maybe it's not a face, maybe it's just a crater. But also, this tells a bit of there's a sad undertone to this in that first example I gave you with the Retalak and the authors from India and the follow-up authors from India, though that was all take place in reputable journals across, the Geological Society of India journal, Gondwana Research, all proper
Gondwana
peer-reviewed
Research
one.
is a good journal. Like,
Yeah,
it's a
this was all
well-respected journal.
scientific discourse taking place in a proper way. This one is a bit sad. This New York Science Journal, I was like, what the hell is this? And I looked into it from this thing called the Marsden's Press. They are listed as a predatory journal, right? So they are
Right.
a journal that will take money from people to publish this and uh, publish it. And I looked through some of the other things published in the New York Science Journal. People have presumably paid money to publish in this, and it's all things often from the developing world, from authors that, are potentially being taken advantage of. So it feels a bit sad in this whole instance. I've just immediately gone from this cruel poking, laughing at it, and then I'm now being sort of sad about the effect that this has on global science and development. So do be aware about these sorts of things. The Fossil Files listeners, I'm not telling Susie that. I'm sure you're already aware of predatory journals.
But it is a really good point, that they
Yeah.
they are they're just scammers. They're just
Yeah, the
grifters, aren't they?
scammers.
They're just taking advantage of people, yeah.
How many emails in your email box a day do you get asking to publish in the Journal of Dentistry or Aquaries, Fisheries and whatnot?
I know. I mean, yeah, you look at your junk mail, right? And it's just
Hmm.
there must be 20 a day, something like that.
Yeah.
Something in of
So
that order.
that's the level of the scam we're talking about here. For those that are not academic out there, any academic who has published a paper, you share your email address and then you instantly get loads of invites to publish in a special volume of greetings, dear friend. Happy greetings on this fine day. Publish in our special volume. Do you have an idea that you want to submit to the Journal of Orthopedic Surgery? No, I don't have an idea of all things I want to submit to the Journal of
I
Orthopedic
work on
Surgery.
fish. They don't have
Yeah,
feet.
yeah.
God.
So whilst that is a very serious, bittersweet point that I'm pulling on here, I'm still going to say that this is batshit insane. This this 10-kilometer embryo of a sauropod. Go and find out. If people want to Google it, it is called Dinosaur Eggs with Fossilized Embryos on the Moon. Enjoy. So
Yeah.
next week, Susie, you're going to be. I mean, before we move on, we probably should think about what sort of take-home messages we've had here. What are the take-home messages that people should be thinking about?
Don't publish in predatory journals. Check your sources. And if you think that you see Jesus on your toast, just apply some scrutiny and some common sense to whether that is in fact Jesus on your toast. Those are my take-home messages from today's episode.
Okay, so hopefully if I follow that advice, I won't end up in a future episode of paleontological fails. I'm now getting a mad sweat on that some other podcast somewhere is now rooting around in my publication history to say, do you know what Sansom did in 2013? Look at them.
Well, I know
idiot.
that there's at least 20 dino nerds out there going, oh, what about that time when you synonymized taxon X and taxon
Yeah.
Y?
And actually, I think that's an important point to conclude on, actually, is that science is an iterative process. Mistakes happen all the time. I've made mistakes. Yeah, they get corrected in the literature
Well, but
and you move
there's
on. Yeah,
there's mistakes, and there's also making an interpretation based on the data that you have
yeah,
available to you at the time,
yes,
and then more data becoming available, which allows you to
yeah.
then go, oh, actually, what I thought then is, I wouldn't describe that as a mistake. It's just that
That is,
the
yeah,
data that, like, particularly when we're doing phylogenies, Rob, right? We
yeah.
might
Oh, yeah,
say
yeah, yeah.
that these phylogenies, every single time you add a new taxon, you get a new set of evolutionary relationships. So it doesn't mean that your
Yes,
old one was wrong. It just means
absolutely.
that was what the answer was when you had that data, and now you have new data that you can
Yes,
add to this picture, and it suggests a
absolutely.
different story. So
Science
yeah.
is an iterative process, and when new evidence comes to light, especially with phylogenetics, I've often had this with my
Mm.
PhD students after training. Well, no, this phylogeny won't be the last one, right?
Yeah,
This
it's not
is
the answer.
No, indeed. And we had a big new phylogeny come out from Emma Randall's PhD this week, in the same
I
time that
saw.
you.
Congratulations. I
Oh, thank
did.
you. Not quite as exciting as your Spicomelis one, but it took 10 years to get to that point. And it took so long because no one had ever done a phylogeny for this group of fossil fish before. And it almost certainly won't stand the test of time. But it was the first one, right, for the
Yeah,
whole group.
absolutely.
So
And
we needed to get
Emma's
it out.
work, well, amazing. And Emma's work will form the basis of every other heterostrachen phylogeny that
Exactly.
will occur going forward. And people will find
Exactly.
different things, but that hers will be the foundations. You know where you should have published that? In Journal of Systematic Paleontology, Rob.
Oh, sorry. Well, we did. Some of her PhD we did publish in the Journal of
Well,
Systematic
I'm
Paleontology.
pleased to hear that. I'm pleased to hear that. It's just because I'm the editor in chief these days,
Yeah.
so you should definitely say.
Yes. Okay. So, Susie, next time you're going to tell us about another paleontology fail, Oculodentavis. Although I guess I'm not
Oh,
allowed to call it that anymore because does that name exist anymore?
well, it will still have the name. It just won't be what they said it was, will it? I don't
Oh
know.
yeah,
But
okay.
anyway, yeah.
So
The
this will
name
be
will still
quite
exist.
that'll
Yeah.
be quite a high
Oculodentavis.
profile snafu. Let's call it that,
Yes, let's.
with all sorts of issues relating to ethics and
We
science.
have mentioned that briefly before.
We have, yeah.
Oh,
Great, thanks,
that'd be fun.
Susie. I'll see you next time.
See you then.
The Fossil Files was presented by Robert Sansom and Susanna Maidment. You can find more information, including links to the original papers that were discussed, at fossils.libsyn.com, and you can contact us at fossilfiles.pod@gmail.com.